So we're back at our two-plate method rig. We've got our one-way lighting circuit installed, and you've seen over a series of videos I've explained the connections in the switch and the connections at the lighting point, and then we changed it over to the easy fit connectors from Collingwood. So the first test, Joe, being continuity CPC, we're going to measure all the readings at all the points and recording which one?
We're going to be recording the highest point. Again, don't get confused and think you record the end point. It's the highest value you record.
But I've got a little bit of issue now because I've got these easy fit connectors. Can you explain how I'm going to make my connection for that continuity test?
Yeah, absolutely. So you might look at this and think, well, the end of the circuit is on this fitting here because this is after the connector. However, this is a double insulated fitting, so there's no CPC connection to this. It doesn't have an earth connection. So what we're going to be looking at is we're going to be looking at testing within here. So we're going to test in here and in here because we test at every point.
We do.
So in order to do that, I think the best way of doing that is simply to unplug the LED light fitting, because we're going to have to do that anyway when we do our insulation resistance test.
Good point.
And then test across the pins, which we'll be able to access on the end there.
Okay, so we're going to test at the light switch, we're going to test at lighting point 1, lighting point 2, recording the highest reading, and we're also going to include our polarity test at the same time, so obviously we're going to operate the switch. So that's a little bit different than what we've seen before when we had our basic one-way lighting circuit for two reasons. We've got the two-plate method and we now introduce LED lights. I think if we bring the camera in next, let's see how we're going to perform the first test, continuity CPC and polarity. So a little bit different from my early videos I've done on GSH Electrical. I've started now actually putting the line conductor into the earth bar where the CPC is connected. It doesn't matter which of the terminations it goes in, but that actually physically links the two together rather than using my crocodile clip and link, because we've had some issues with the resistance of that and removing it. And obviously the clip itself is starting to become unreliable. This is a more reliable connection where I've got the line conductor in the bar with the CPC. We're now ready to set up our test instrument to carry out the continuity test. So Joe, we're about to set up our Megger MFT to carry out the continuity of CPC test. Can you do that setup for us, please?
Absolutely. First things first, let's get the leads in the right place. So we've got here our L1 and L2 terminals. So that's where we're going to connect our leads up. And of course, we like to get the colours matching because otherwise Joe's OCD gets triggered. So let's have a look at this then. So we're going to set it to measure a low ohm setting. So we're going to measure low ohms, turn it to the orange setting on this Megger MFT, let it do its initial warm-up, and then you can see that it's looking for it. Now it's important to remember with this type of tester, it's testing all the time. So it's currently trying to test what the resistance of the air between these two probes are. We're going to zero the leads before we do anything. So we're going to clip these together, and notice I'm using the fixed jaw connected to the fixed jaw, because what that does is it gives us the most reliable connection. And instead of putting them across each other, I'm going to put them long ways like that, and that allows you the best contact across the greatest surface area. Now interestingly, on the multifunction tester now, it's showing that we've got less than 0 ohms. That's because this has maybe been zeroed with a different set of leads or something like that. So then we press the test button, which in this case is the zeroing button, and you'll notice the little 0 symbol here has gone. So 0.13 ohms is the resistance of the leads with this connection. So I'll just make sure that that's nice and tight there. So we've got 0.14. If I now press the test button again, you can see we're now at 0. It's not saying less than 0, so we're ready to start testing. We've got the little 0 symbol there, and we can ready to do the test.
So we've connected together the line and CPC within the consumer unit. We're down at the first switch, and in this case the only switch, and we're going to test between the line conductor and the CPC. We're not going to operate the switch at this stage. We're just going to prove that we have a CPC at the actual lighting point itself. Joe, just remind me, do I need a CPC down here at this point?
Because this is all plastic, the CPC is technically not required at the moment. However, it's best practice to take a CPC to every point in the installation, because at some point in the future, this may well be changed for a metal-clad version.
Okay, making it an exposed conductive part. Okay, brilliant. Let's carry out the test then.
Okay, so we're just going to connect across the CPC connection in the back there and the line connection in the front. Okay.
And we have a reading of, when it settles down, of 0.18.
Very nice.
0.18.
Very good. And of course, if at this stage you haven't got a reading, it may be that your switch is off, or perhaps you're on the wrong side of the switch itself with the switch in the off position. So it might just be worth, if you've not got a reading, that should really be the first thing that you think about checking.
Okay, so the easiest thing is for me is just to drop down into the other hole and then obviously pick up the other brown conductor in order to do the test. So we're doing it at the switch. Well, that's the first one. We've now got to go to every lighting point in circuit. We've only got 2. Of all the readings we get, Joe, which one we'll record?
We'll be recording the highest reading. Don't just go to the end of the circuit and presume that'll be the highest reading. Sometimes there's T's and things that you can't see behind the scenes.
Okay, so let's go to the lighting point next. After testing at the light switch, we come up to the easy fit connectors. These would normally be in the ceiling. We've got our LED downlighters. Let's just confirm again. We can clearly see on the side there the symbol for double insulated, even though it's metallic. The CPC is not required at this point. Therefore, we're going to test at the easy fit connectors themselves. Joe, do you want to do that for us?
Absolutely. So it's just a matter of pushing down this little plastic spring there, and that just pulls apart really nice and easily. You can also see through the plastic, you can see which terminals we're aiming for. So we've got our line connection here and our CPC here. So we're just going to connect across those. So make our connections really nice and firm.
And we've got a 0, oh, just slipped off there, Joe, a little bit.
Yeah, just a little bit.
Got a reading of 0.18 if I operate the switch. We're getting full scale deflection. And we're back on again, so we've left it on. So 0.18, if you would like to do the second one for us, please.
Absolutely. So by flicking that switch there, Gary, what have we actually proved by that?
Well, we're proving that the line conductor opens and closes, now the breaks and makes it within the circuit itself.
Yep.
We know that we've connected the line conductor and the consumer to the CPC, and this is all part of the polarity test. We've also done a visual polarity up here by confirming the line conductor and CPC. We can also see the neutral, so that's all part of the polarity test.
Absolutely, making sure that that line conductor is being switched and we're not switching the neutral. It's very important.
0.21, operate the switch. And again, we're going to leave it in the on position, remembering the highest of all our readings. Remember, we're on a very small rig, we don't get very large readings. So we left it on because which test are we going to carry out next, Joe?
So next we're going to carry out our insulation resistance.
So we've reconnected the line conductor into the top of the 6 amp type B circuit breaker. We've confirmed its torque settings. As we're mimicking a domestic installation, we've got RCD for protection, offering additional protection rated at 30 milliamps. It could be 30 milliamps or below. However, Joe, with the cover back on the switch and the switch left in the on position, there's still some precautions for insulation resistance testing.
Absolutely. So inside our LED light fittings here, there's some fairly delicate electronics. 2 things could happen. Number 1, we'll get a false reading when we do our insulation resistance across line and neutral. And also we could damage the innards of this, and we don't want to do that when we're pumping 500 volts through it.
What we could do on electrical installation condition reports is actually carry out the insulation resistance test first of all at what voltage before we up it to the 500.
So we could attempt it at 250 volts to start with, and if it's clear at that point, then we could think about going to the 500. That's in situations where you're not sure if you've left a load connected or something like that.
And that's something that perhaps Marcus is going to explore in further videos that you can watch on Marcus, which is in his fault finding and testing section on a playlist within GSH Electrical. Nice and easy for us. I think we can see the light fittings are connected, Joe. How easy is it going to be to disconnect them from the circuit?
Well, I'm going to have to go inside here. I'm going to have to open up the junction box. I'm going to have to undo the connections, and I'm going to have to think, well, when I redo those, I'm going to end up damaging those delicate stranded conductors. It's just... Or how about we just disconnect those connectors like that, just nice and simple.
So we've now disconnected the sensitive electronic components within the LED fitting. As always, we've left the RCCB off because we know that's got sensitive electronic components in it for my learners and Joe's learners. We also leave the breaker off even though we know there's no sensitive electronics, because the test actually goes out and through the circuit, but it'll also go down. So if we left this on, the circuit could have 500 volts through here, and the insulation resistance could be across the bottom of the RCCB. Is the electronics at the top, Joe, or the electronics at the bottom?
We don't know.
We don't know, so we always say to leave that off. And we're just going to carry out the standard insulation resistance test from in here, remembering the important part of this part of the video is that we've disconnected the sensitive electronic components within the LEDs and the RCCBs. We're going to bring the camera in, Joe. Are you happy with that?
Absolutely.
Bring the camera in and we'll just see what we can do in here when we carry out the insulation resistance test. So can you set up, please, our Megger MFT in order to carry out the insulation resistance test, please?
Absolutely. So we're going to change this now to our 500 volt setting. So we're going to change that so when we press the test button, it's going to inject 500 volts DC into the electrical system. Now, a couple of things just to note. At this point, the tester stops testing all the time because we wouldn't want to have 500 volts across the ends of these probes without that being under our control. That could lead to a bit of an accident. And also, it's worth noting at this stage that there are times when your test leads may snap down here internally, so it may be that the flexible copper inside there can give way over time, because obviously we know our leads get a fair bit of abuse in the workplace, and what tends to happen is you don't notice until you pull that out and you've lost your connection. So at this stage, it's always a good idea just to quickly check that your tester is working as you'd expect it to. So if we press the test button, we get a phenomenally high reading there because we're testing the resistance of the air between our two probes there. And then it's a good idea just to connect them together to make sure that your leads are doing their job, the tester's working properly. And when we do this now, we should get a very, very low reading. Just slipped off there, try that again. So we should get a very, very low reading. Very nice. So that just helps us to see that we're going to get the readings that we should be getting, because obviously when we do the test and we get a huge number greater than 999 megaohms, we're assuming that that's because the insulation is doing its job in the installation. But what we don't want to happen is for this to have snapped inside here and for us to get that really high reading no matter what's happening.
So this is the first time in a long while we're having two people doing this. So I'm behind the camera, Joe, so I can tell whether your hands are blocking the view, because everyone says to me, I can't see what you're doing. Okay then, so insulation resistance testing then.
So what we're going to do is we're going to test all combinations of conductor. So we've got 3 conductors, which gives us 3 tests. So what we're going to do in this case is, first of all, I'm going to test between line and neutral. So in doing this, obviously getting onto the neutral bar is really, really nice and easy. We've got no problem there. And putting this probe here into the top of the circuit breaker is normally fine. But again, a little bit of an issue here you just need to be careful of, because we've got quite short tips here, as you'd expect them to be. What can happen is that sometimes the end of the probe doesn't quite make the contact with the metal, but the plastic bit kind of sits on the edge of the screw kind of gap. So it feels like you're pressing in really hard, but it's not actually making contact. So it's a good idea just to make sure that you are actually got the tip of your probe onto the metalwork of there. Otherwise, again, you'll get a really high reading, which is what we want, but it won't be because you're making a connection. So let's test away.
So greater than the machine can read, so we would record plus 999 megaohms, Joe, so that's a fantastic reading. Happy
days, right, so now we'll go and we'll do line and CPC. So again, making a good connection inside our line terminal there, and we'll go onto the earth bar up here.
Again, greater than 999 megaohms. Now that's mega or mega? Or Mego? Well, Joe, do you do the next test just to have that discussion?
Yeah, I don't really think it matters that much, but people will comment, so it's fine. I normally say mega ohms.
So do I.
I'm sure there's going to be some comments popping up at this point in the video now. And now we'll test between neutral and CPC. Having said that, of course, always happy to be corrected if we do make a mistake.
Greater than 999 megaohms, okay, fantastic. For that. So what's the...
I'm going to say greater than 999 megaohms, Gary.
Okay, megaohms. Okay, thank you.
We've covered all bases.
There's no Gary order for this. There's no Joe order for this. We've just got a test between all 3. We've only got 1 circuit. Again, check out other videos on the channel where we've got multiple circuits and how you carry out an insulation resistance test when you have more than 1 circuit in play. Just remind us, for an existing installation, what the smallest acceptable value of insulation resistance is, Joe?
So the smallest acceptable value is 1 megaohm.
Okay, and we require further investigation when the overall insulation resistance of the circuits fall below
2 megaohms.
And we have to do, for a brand new circuit, according to Guidance Notes 3, have a reading that is greater than 20 megaohms for a brand new installation. We've done that with this one. We've got greater than the machine can read, greater than 999, and you're going to say?
Megaohms this time. Let's keep it fresh.
Okay, so we're going with megaohms. Okay, thank you.
Just one more point before we finish. It's critical if you're doing this in a real world installation, when you do your insulation resistance test, the regulations require that you have your main earthing conductor connected. So we want to make sure that that's in place. Obviously we're in a simulated environment here, so we don't have that conductor installed, but when you go out and do this in the real world, potentially when you do this in an exam, you want to make sure that you've got that conductor in place.
And that doesn't mean we have to have the line and neutral, it's just the earthing conductor connected to the external earth source. Good point, Joe. So raised some interesting points there. If nothing else, that I still say Megger ohms, and you sometimes say
Megger ohms.
Okay,
I like to flick between the two.
Yeah, okay. So that's some comments we're having on the channel. So let's reiterate some of those points. Obviously, we've disconnected the sensitive electronic equipment, Joe.
Yep.
And for us at this stage, we're going to reconnect those because our learners don't do at this stage any of the live testing. So would you like to put those back in, show us how easy it is again to reconnect?
Absolutely, and again, what an absolute fantastic idea this is. So the fact that you can do your testing really nice and thoroughly, get all the readings you need, but you're not causing yourself an immense amount of hassle in terms of disconnecting and reconnecting those fittings.
And I love the fact they're clear, so you can do a visual polarity check. Insulation resistance test, we clearly said again, the one conductor that must be connected from the tails to the external source is the earthing conductor. Remember AM2 and AM2S, that might be something you need to reiterate and make sure is in place. Our switches are left in which position for this test?
So for the insulation resistance test, we leave them in the on position because that means that then we're testing every scrap of insulation as far as we can inside the circuit.
We've completed 3 tests in this video. We've done the continuity CPC, recorded under the box heading R1 plus R2, R1 standing for?
The resistance of the line conductor.
And R2?
The resistance of the CPC.
And that's what we measured, and we record the highest of our readings for that. We also completed the polarity test. What did we put in the polarity box, Joe?
We just put a tick.
I'll put a tick in the polarity box, and for this one we're going to record all 3 readings for our insulation resistance test, and they were all greater than the machine can read. And Gary likes to put plus rather than the greater than sign because often my students put it the wrong way round. Okay, so I prefer plus. So that's all the things we've covered in this video. We're going to go on in the next video to change it to 2-way. So we'll look at the connections for a 2-way circuit when we've taken the feed to the switch, the 2-plate method, and then hopefully Joe will join us again and we can redo the testing in that video. Just need to say the last thing, Joe. What we're going to say?
We hope this video has been some help.
Been some help.
Really, on my own? You just leave me hanging?